Between statistics and calculus, I'm just learning all the letters.
Okay?
D's and D's and D's.
Here is the integral test. So if we have a positive, continuous, and decreasing function, then if our series, and the series and the integral both converge, or they both diverge. So write it down, and then I'll basically tell you how we're going to use it.
We just pretty much always assume A sub n is F of n. Will there be situations where that isn't true? Considering
When we get to alternating series, it's going to be like -1 to the n times f of n. Okay, so basically this is saying that if we look at the integral from 1 to infinity of f of x, and it converges, then the series of f of n is also going to converge.
the integral from 1 to F of x.
If we look at the integral from 1 to infinity of f of x and it diverges, then so does the series of a sub n.
But you can't say that it gives you the summation because the integral gives you small. It's not quite.
Well, see, the integral is giving us the area under the curve, and that's not necessarily what we're looking for, okay? So there's a way for us to, like, find, like, an error bound on this, but, and we can approximate it, but we can't actually find what it converges to. Now, if you are going to use this test, you have 3 things you need to make sure your function satisfies. It has to be positive, it has to be continuous, and it has to be decreasing. Now this says for x is greater than 1 because here we start at 1 and go to infinity. There will be a few times where you might have a function that is decreasing from like 3 and beyond, and that's okay. Like if it eventually if it increases, or if it doesn't decrease for a couple terms, but then decreases towards infinity, that is okay. We just need to decrease towards infinity. Okay. So I need to see that you thought of these 3 things before you looked at the integral. Okay. Continuous and positive, those are easy to check off. Decreasing. How do we tell whether a function is decreasing?
Derivative test.
We need to look at the derivative.
I called it. You are too good.
First one. Now I realize that this one we don't have to use the integral test. What could we use? This is actually one from your homework.
Yeah. Geometric
The geometric series.
Wait, oh, yeah.
Okay, we know that this is 1 over e to the n. Is r less than 1?
Yeah.
Okay, we know it converges. All right, but I wanted to pick an easy one to start out with the integral test. Okay, so we know what the answer should be, right? Awesome. So let's let f of x be e to the negative x. Okay, is our function positive?
Yes.
Yep. Is our function continuous?
Yes.
Is our function decreasing?
Yes.
This is the only one I want to actually see your work for, positive and continuous. I don't need to see anything for that. I need to see that you physically checked it off of this list. But I do want to see the derivative. Why does it have to be positive?
Says,
Because when we take the integral, we're finding area. So we want to have positive area. Okay. So here we go. So we're going to find the integral from 1 to infinity of e to the negative x dx. Okay, so remember we're going to have to write this as the limit as some other variable. I'm going to choose a. Can you tell why I waited to go over the way back Wednesday until today? What's the antiderivative of e to the negative x?
negative e to the negative x.
So we have the limit as a approaches infinity of negative e to the negative x evaluated from 1 to a. So we have the limit as a approaches infinity of negative e to the negative a minus a negative e to the negative 1. This is essentially negative 1 over e to the a. As a approaches infinity, what happens? Goes to 0. So what is our... Okay. So, since the integral from 1 to infinity of f of x dx converges, then our series converges by the integral test. Yay! Now, what's nice about the integral test is it can be used often. What stinks about the integral test?
You have to.
It's going to be the most work. Okay? But it's one that we can sometimes fall back on if we get desperate.
Plus you can get some calculator, right? So you just set the inconvenience as like a really large number.
No, we're not.
Okay. Then how about a worksheet?
Next one. Okay, now this one begins at 2. Why is it not beginning at 1?
Because that goes zero, and that has
Okay,
It's a first term.
natural log of 1 is 0.
Yeah.
Okay. It is okay that it's beginning at 0. It's okay. I mean, it's okay that it's beginning at n equals 2. I don't know why I said 0. It is okay that it's beginning at 2. So, we'll just let f of x be the natural log of x over x. Is this positive? Yes, because we're beginning at 2. Is this continuous?
Yes.
We have an asymptote at 0. So yes, it's continuous. Is it decreasing?
Oh no.
Okay. Low D high minus high D low all over low squared.
Yes.
Is this?
Yes.
It's less than 0,
Is not plotted.
e and after, right? When x is greater than e, so that's okay. It eventually is, it's decreasing
Yeah.
fairly quickly, okay? So for a couple terms, we're not, but then it goes to decreasing, so we're okay. All right, so now we're gonna look at the integral from, what's our lower limit of integration? Thank you. Okay, it has to match whatever the series has. So basically, we're looking at the limits as some other variable approaches infinity from 2 to that variable of our function. How will we ever take the antiderivative of the natural log of x over x?
Use substitution.
It's just you.
If u equals the natural log of x, du is,
1 over x.
oh man, that's nice. It is that pretty.
All of the other ones.
Oh.
Oh.
So we have the limit as a approaches infinity of
1/2.
u du, right? Which is 1/2 u squared. So now I'm going to go back to x's. Okay. So what we really have is the limit as a approaches infinity of 1/2 natural log of x squared evaluated from 2 to a.
Fun.
It actually is quite nice. So we have 1/2 times the natural log of a squared minus the natural log of 2 squared.
No, because it's not.
What happens to the natural log of a as we go towards infinity? It gets bigger and bigger and bigger. And so what about natural log of a squared? It's gonna, well, we're still gonna go to infinity. So this diverges. Okay, therefore,
Yeah.
yes, you could. Therefore is the same as this.
Whoa, new math terminology. Can we spend a day this morning all these funky math terms that teachers use for us?
That way this also diverges because
Also.
it actually wouldn't take all day for me to teach you the symbols.
Let's do it.
When we have time.
We have 30 minutes.
I know, but we still need to go back over the way back Wednesday.
Oh, yeah.
And
We
whatever
need to do
piece
that. That's in us.
Okay, I'll give you an easy one. This is you. You do this in your notes without my guidance.
Okay.
It's you because it's you substitution.
No.
It's just normal distraction.
Pretty sure you can do this one without substitution.
I substitute you x.
It's mighty nice. Proteins and food. It's mighty nice.
that also the same?
No.
Um, It's basically the same number.
It rounds up.
If I was grading the paper, I'd say it was the same.
Where would this function not be continuous at?
Zero, but if we don't start. The function would be discontinuous at decimal. This number. Because technically sums don't touch decimals.
Right, but if we're gonna do the integral, we can't interpret it.
Could you use a different decimal? Is there a different decimal? Functions that just have functions that have just would have sums that don't, sequences that don't.
Because we, if I say the sum from n equals 0 to infinity of 1 half to n.
Okay. That's what I thought.
Hold on. Wait, hold on.
1 over n minus 1 half.
Uppercase.
Right.
Or 1 over n minus 2 half.
Well,
Alex, do you remember a good variable?
I went with Smigel test is.
I know. That's why I said.
Use a hammer and a sickle. Yeah.
I actually really like this.
Husky's probably close to 8. Rounds up.
When was the bar? 1/2. Because somebody gave the job to the girl. Like, would you go?
I should have.
And the girl said,
I don't know.
yeah, you want to win. Oh my God, it's like that. Did she, okay, did she go undergrad? No.
Well, like,
Really?
Okay, so.
I don't write it.
So like on the back end.
Did you get them to go along?
I just integrated it.
Okay.
This is how our daughter, she has a bar, she goes, oh.
Are you doing the car company?
Initially, when I got home at like 6:30, I was outside by 10.
No, diverge.
Oh.
Who votes for converge? Ooh, okay.
They're all wrong.
What did you get as the area under the curve?
1/2.
1/2.
That's my case.
Oh, yeah, I read it.
Okay. Excellent. Now, what I want you to think about okay, well, write down what a p-series is. Okay, so a p-series, 1 over n to the p. So, our previous example, 1 over n cubed, that is a p-series, where p is 3. When p is 1, this is called the harmonic series. Anybody know why?
Because it was harmonic with,
Half, 1/3, 1/4, 1/5, 1/6, 1/7.
Because it approaches one. Some approach.
It actually does have to deal with music.
Ooh, harmonic. Yeah.
Like-
waveform.
Like,
Oh.
like if you think of like a guitar and where you would have to like divide the string.
You play guitar, you should know the strings get VA.
Oh, yeah.
They do this proportion, they do that proportion.
Okay, yeah.
There's a name for this kind of distribution.
The harmonic series.
Is it?
The harmonic distribution.
It is called the harmonic series.
No, there's a name for this graphical distribution.
The harmonic sequence.
The harmonic.
No, it's named after someone, because it's the basis for
Well,
your.
because
Mark
that's
Harmon.
Basis for such.
So this is what I want you to think about. We have rules for when our P series converges and when it diverges. Okay? When P is 1, when P is less than 1, when P is greater than 1. So I want you to think about when those would converge or diverge. Okay, we did do a P series where P was 3, so keep that in the back of your mind. Maybe if you want to think about what the integral of 1 over n would be, and what that limit would approach towards infinity. Okay, so write down your yeah. Using intuition, write down what you think.
So P is always in the denominator.
Yes. So let's think about, okay, I'll give you 30 seconds to write down your intuition.
Institution.
Okay, so we're going to talk about the harmonic series first, and P is 1. 1 over n, positive, continuous, decreasing. What's the antiderivative of 1 over n?
Natural log.
The natural log of n. So what we would have is the integral from 1 to infinity. Oh. The antiderivative is the natural log of x from 1 to a. What's going to happen with that? It's going to go to infinity. That's going to diverge. Is that what you thought?
Yes.
Yeah, now
I'm going to jump down to here. P is greater than 1. If we think about y, 1 over n squared, 1 over n cubed, 1 over n to the 4th, those are all going to have antiderivatives where n is still in the denominator. And so part of the limit's going to go to 0 and you're left with a value. Okay? What about when P is less than 1? That's going to have to diverge. Okay, if we think about like 1 over n to the 1/2, right? What's the antiderivative of 1 over n to the 1/2? 2n to the 1/2. Okay, so towards infinity, that's going to get bigger. That's going to diverge.
Would this be, if P equals 1, would that be a case of whether you get past the anti-term test and still diverges? Because if you
Both of these. Both P equals and P is less than 1.
That is P equals 1. Well, I would just talk about P equals 1. Here are P.
Any P series is going to have a limit of 0 towards infinity. These are the ones that diverge, these are the ones that converge. Okay, so yes, like Nathan said, here's an example of the limit of the sequence is 0, but it's not gonna converge. Okay, so that converse isn't true. Okay, so this is about the easiest test that we have. Okay, geometric is pretty easy, but I'm gonna ask you to like find the sum of a geometric series. We can't find the sum of a p-series. We can approximate it, but we can't find the actual sum. All we can do is say diverges or converges. Okay, they're very easy to recognize.
Okay.
Does this converge or diverge? Okay, and what I would want you to write, this converges because it's a p-series where p is greater than 1. Done. On to the next problem.
So that's all the explanation you want?
Yep. Now, you may have some p-series in disguise.
This is 1 over n to the 1.5, which is divergent p-series p.
Okay, so I would want to see that you rewrite it so it looks like 1 over n to the p. And then I would want you to write, okay, this diverges because it is a p-series where p is less than or equal to 1. Done.
Why is it less than or equal?
Because we just established the
Because
the
it's-
divergence.
yeah. So I'm just going to group those together.
Oh, yeah, yeah, sorry. Spacing out.
Okay, write down your homework. EOO is every other odd.
1, 5, 9.
Why do you have that one go to 11?
Yeah, I could have read, right?